All right, let's talk about, well, everything. The entire universe. We're going to see how everything you can see, touch, and feel, all of it, can be boiled down to just two fundamental rules. That's it, just two. I know, it sounds a little bit like science fiction, right? But what if it's not? What if everything, and I mean everything, from the chair you're sitting on right now to the very light hitting your screen, is just the result of a simple split, a cosmic choice between only two ways of behaving? Yup, that huge cosmic choice all comes down to the number two. See, every single fundamental particle in the universe, it has to belong to one of two families. You've got the fermions, and you've got the bosons. And here's the kicker. If you can understand them, you can understand how reality itself is actually built. Okay, so let's dive into reality's two master rules, the fundamental division in the quantum world. Think about it like this. Every particle that exists, from the tiniest quark to a single photon of light, has to pick a team. And there's no sitting on the sidelines, no middle ground. The rulebook each team follows, it's completely different, and that's what creates the universe we see all around us. You know, the easiest way to get your head around this is to think of them in social terms. So you've got the antisocial particles versus the social ones. Fermions, they're the ultimate individualists. Kind of standoffish, you know? They really, really need their personal space. Bosons, though, they are the complete opposite. They're the ultimate social butterflies, absolute conformists who just love to hang out in a big group. So what's behind this massive personality difference? Well, it all comes down to a quantum property called spin. And you don't need to be a physicist here, just think of it as a particle's built-in orientation. Fermions, our builders, have this half-integer spin. This is what makes them so antisocial. It's a fundamental rule that they can't have the same properties in the same place. This forces them to build out, creating unique, stable matter. On the flip side, bosons, our messengers, have a whole integer spin. This makes them super social. They absolutely love to match up and pile into the exact same state, which lets them act like one giant unified force. Okay, let's look closer at the first team, the antisocial particle. We're talking about fermions and the rule that creates structure. It's kind of funny, actually. Their total refusal to be like their neighbors is the very reason we have a complex, structured world to begin with. So who exactly are these fermions? Well, they're basically the A-listers of particle physics. We're talking about electrons, protons, neutrons, quarks. These are the fundamental building blocks of literally everything you can touch. They are the bricks and mortar of the cosmos, making up every atom in you, me, and, well, everything. Their entire antisocial behavior comes down to one single rule, the Pauli Exclusion Principle. All it says is that no two identical fermions can occupy the same quantum state at the same time. It's the ultimate personal space rule of the universe. It's like you can't have two identical people in the exact same seat in a movie theater. It's just not allowed. And you can really see the creative power of this rule when you look at how an atom gets built. So step one, the first electron comes in and grabs the best spot, the lowest energy state. Okay, what about a second one? Well, a second electron can squeeze in, but only if it has the opposite spin. So what about a third one? Nope, sorry, it is absolutely excluded. It's forced to occupy a higher energy level. And this forced stacking, this building up level by level, is what creates the entire structure of the periodic table. It's the reason chemistry exists. And this isn't just some abstract, far-off rule about atoms. It has a very real, very solid consequence for you right this second. The reason you don't just fall straight through the floor, it's this principle. The electrons in your shoes and the electrons in the floor are basically yelling at each other. Nope, this is my spot. They refuse to be in the same place. That's what solidity is. All right, so that's team one, the antisocial builders. Now for the other team, the social particle. This is all about bosons and the power of unity. See, if fermions are the architects creating all the structures, bosons are the messengers, the forces, acting in perfect, powerful unison. And man, do they play by a different set of rules. So who are these super social particles? They are the force carriers of the universe. You've got photons, that's light. You've got gluons, the cosmic superglue holding atomic nuclei together. You have the famous Higgs boson, giving other particles their mass. These guys are the agents of action. They're the ones telling the fermions what to do. Yeah, bosons, they love to be in the same state. In fact, the more the merrier. Unlike the fermions, they have absolutely no exclusion principle. They don't just tolerate being in the same quantum state, they actually prefer it. It's wild.
The presence of one boson actually encourages others to join it. It's like a quantum party, and everyone's invited to do the exact same dance.
And this bunching together behavior leads to some incredible things. Just think about a laser. What is a laser, really? It's nothing more than trillions of photons, all of them bosons, acting as one. They're all marching in perfect lockstep, with the exact same energy, same direction, same everything. They become one single, coherent, powerful wave. That is the power of bosons being social. So let's put it all together. Building blocks versus force fields. This is how these two simple rules create one single universe. You have the individualist builders on one side and the collectivist messengers on the other. And it's the beautiful dance between them that makes everything, and I mean everything, possible. So let's recap. The Fermions, they're the architects of matter. Their antisocial rule is what gives us everything with substance. It creates all the unique atomic structures. It's the entire basis for chemistry and the periodic table. It enables the semiconductor electronics that run our world. It provides the stability and structure of the entire cosmos. They literally build reality. Then you have the bosons, the agents of action. Their social nature is what gives us these incredibly powerful unified forces like lasers. It enables wild phenomena like superfluidity and these exotic states of matter like Bose-Einstein condensates, where thousands of atoms literally lose their identity and act like one giant superatom. They're the ones carrying information and making things happen. And look, this isn't just some cool bit of cosmic trivia. The future is quantum. Mastering these rules, understanding, and actually manipulating the behaviors of these two types of particles, that is the absolute cutting edge of technology. It's how we are building our future, right now. Seriously, just look at how we're engineering our quantum future. Our most advanced tech is built on this stuff. Those semiconductor devices in your phone, that's all about controlling fermionic electrons. Superconductors, that's a clever trick where we get fermions to pair up and act like bosons. Lasers in all our photonic systems, pure bosonic behavior. And the Holy Grail, quantum computing, well, that's going to require us to be absolute masters of both. And that brings us right back to where we started. The entire universe runs on a simple rule, and that rule builds reality. An entire cosmos, with all its staggering complexity and action, all of it just emerges from one simple choice that every particle has to make. Are you going to be an individualist builder or a social messenger? Are you a fermion or a boson? That simple, fundamental division, that's what builds everything.